Hello there, developers, and welcome to this day 5, the last day of the ROS2 Learning Week. And today we are going to do a final project where we are going to apply some of the knowledge that we have been learning during this week. First in a simulated environment, and at the end we are going to move to the real robot. So let's go for it. Alright, hello everybody and welcome to this last day, final day of the ROS2 Learning Week. I hope you have enjoyed all this week of learning ROS2. And as I was saying, today we are going to do a kind of final project, let's say, where we are going to apply some of the things that we have been learning during this week. We will also cover one thing that it was not covered yesterday. And first, we are going to work on a gazebo simulation like we have been doing the whole week. And at the end, I'm going to basically connect to a real robot using our real robot lab. And I'm going to deploy one of the programs that we are going to create today for the project. I'm going to deploy it to the real robot and test it there in order to conclude this ROS2 Learning Week. So yeah, let's not lose any more time and let's go for it. So I'm going to change right now to my computer screen here. Let's go. And let me come here to the main ROS2 Learning Week page panel. All right, let me mute this here. Remember, as always, that you can tune the volume here. All right, in case you are hearing it too low or too high, you can tune it here. So yeah, hello everybody. I can see here many people: Jarraya, Bayode, Ricardo, Faust, Reos, Kevin, Arasu. And by the way, I can see that most of the people now has his image in the profile. So you can't tell me that the chat doesn't look much better like this with images in the profiles of people. So in case you haven't yet done so, remember that you can do it very quickly here in your profile page and updating your image so that we can see your pretty face here in the chat. All right, so yeah, welcome everybody. Thanks a lot for being here with me one more day, and we are going to start. So the procedure for today, the setup is going to be the same as yesterday and the last 2 days. So today we are going to be working on a project. And remember that you can find the project just by scrolling down on this page. Scroll down, and here you're going to find the conference documentation, where you are going to find the project of Wednesday, Thursday, and here, the first one, at the first position, you can find the ROS2 Learning Week Day 5 Final Project. All right? So all you have to do in order to get this project is to click on this fork and open project button, which I am going to do right now. So this is basically going to copy the project to your account, and it's going to, as you can see, open it automatically. All right? And keep in mind that we are lots of people right now in this class, so it might take a bit longer than usual, a couple of minutes, something like that. So just be patient. And let me open here another page so that I can still see the chat and everything. Well, in fact, I can see it there, but okay. So how are you guys? Are you ready for this final day, or are you tired? Do you feel energetic? Ready. Okay, I like that. I like that. Even though it's the last day, we have to keep our energies high. Okay? Will this documentation be available even after this class will end? Yeah, yes, Mirna, it's going to be available. So now that you are saying this, so this class is being recorded, all right, and is going to be updated when the class finishes to YouTube. Okay. Now that you are saying this, I want to comment about yesterday's class where we had some issues and the recording. We don't have the full recording of the class, which yeah, it's not the best of the options. However, we have yet uploaded the video to YouTube. You can find it here in our YouTube channel. Let me come here to YouTube and the construct. Right, so this is our YouTube channel, which, by the way, we're getting close to 30,000 subscribers, which is quite a good number. And yeah, so here we are uploading all the videos. As you can see, day 1, day 2, day 3, day 4, and of course, day 5 is going to be uploaded also, okay? And you're going to find many other videos, podcasts, and many interesting things related to ROS and robotics. All right, so in case you didn't know our YouTube channel, please come here, have a look, and subscribe, of course, to our channel. So yeah, here is where we are going to upload the video after this class finishes. And great, so in my case, I can see that my project has been loaded properly here. I'm going to maximize here so that I can see the chat here. So first step is done. Let's go, ready, yes, go, ready. Okay, so first step is done. I have the ROSject here, open it and load it. Let me know also if in your case you have also been able to get the ROSject and open it without problems. Let me confirm here in the chat so that we can keep moving all together forward. Any issues so far? Yes, no? You should basically have this environment, the same as I have here with the notebook. Automatically open it and make sure that is this notebook, the one for day 5, okay? No. Yes, loaded. Okay. Ready or loaded. Okay. Maybe yours is still loading, so just be patient. How about the contents of learning weeks? What do you mean, Tesfa? The contents of learning weeks? I don't get your question. Notebook loaded, so far so good for me. Perfect. So let me start commenting a little bit. So as always, I want to remind you about the new course, our new course, ROS2 Basics for Python, which I have left a link here, a couple of links here, where basically is a complete course where you're going to find the full documentation of ROS2 basic concepts from all the basic concepts that we already covered on Wednesday, topics that we covered yesterday, and also other additional contents like services, actions, debugging tools. And yeah, it's a super complete course that is going to provide the basic, at least all the basic knowledge that you need to know in order to start working with ROS2. All right. So it's a nice complement to this learning week. So yeah, have a look and go for it. I really recommend it to you. And also, besides this course, okay. Let me go back here. Let me refresh this. I think I clicked on the link and it was opened here in the notebook screen. Okay, no issues here. All right, and also let me remind you one last time about the ROS Developers Day, which is going to be a super interesting conference that is going to happen very soon. As you can see, June 19th is going to be a virtual conference. The procedure is going to be very similar to this learning week. So we are going to have different speakers that are going to do different speeches, but all of them are going to be based on this environment, and all of them are going to be practice oriented, all right? So in every presentation, you can see here all the speakers that are going to come to this year's conference. Super cool speakers. Also, you can have a look at the agenda to see the different speeches. What are they going to be talking about? As you can see, there are many of them which are related to ROS2. And as I am saying, yeah, it's going to be very similar to this conference. So all the presentations are going to be based on the system where you are going to have this notebook and you are going to be able to practice. So it's not going to be a conference only about listening to what each speaker is going to say or to present, but you are going to be practicing, all right? At the same time, you are going to be practicing. So yeah. Also very recommended. Have a look, and in case you are interested, register for it. So you are still on time. All right. And yeah, so that's all for this initial presentation. Let me close all this. And yeah, so the next step is going to be how to launch the simulation. Let me have a quick look at the chat here. It depends on what you want to do. Yeah, that's right, Temp. It depends on what you want to, you want to do. Is there a method to prevent the environment from disconnecting due to timeout? Is there a method to prevent them? Which environment do you mean? This one? This one, no. Due to timeout. Do you mean because of inactivity or why? Watch. All right, so let's start. Then the first thing we are going to do here to complete the initial setup is to launch the simulation. So today we are going to be working with a different simulation from the last days. However, in order to launch it, the idea is the same, super simple. So we are going to start by opening a fresh shell here, and we can directly copy and paste the commands that we have here from the notebook to the shell. All right. So first of all, we are going to launch the simulation workspace as we have been doing these last days, and then we are going to execute this ROS launch command. Okay. ROS launch real robot lab main.launch. As you can see, this is a ROS1 command. Yeah, it's ROS launch, not ROS2 launch. Okay, but don't worry, I'm going to explain in a moment why this is like this. So yeah, here we have launched the simulation. We have started the simulation server, the gazebo server, and now in order to visualize this simulation, we need to open the client. Okay, remember that you can open the client by clicking on this cube-like icon. There we go. So now here, I'm going to be able to visualize the simulation. Okay, then at first you are going to see all of this gray. Okay, so you just need to zoom out. Okay, you just need to zoom out a little bit in the simulation, which I am doing right now. It's not detecting me. The zoom, maybe? Okay, let me try from here. Okay, there we go. Okay, now. Yeah, so at first you are going to see the screen in gray, as you have seen in my case, but you just need to zoom out a little bit, the simulation, okay? And you are going to be able to visualize it properly, all right? So as you can see, the simulation is a bit different from these last days. First of all, we have changed the robot. So we are still working with the Turtlebot 3, but now we are working with the Turtlebot 3 Burger model, all right? So until now, we have been working with the waffle model. Okay, so a little difference here in this case with the robot and also with the environment, as you can see. All right, so we have changed the environment because our final goal today is to deploy the program that we create to the real robot. So because of this, the idea is to start working with a simulation which looks similar, which is equivalent to the real environment, all right? And the real environment we are going to be working with, it's this one of the real robot lab, this one here, yeah? So that's why we are going to be working today with this simulation which resembles this real environment, all right? So yeah, at this point, we are almost ready. There's one step more, but I'm going to stop here at this point so that everybody gets on the same page. So basically the setup should be like this, all right? You should have the simulation loaded, this one with the Turtle3 burger and this lab environment, and yeah, this and the notebook, of course, in order to keep following the instructions and all the steps, all right? So let me have a quick look at the chat and confirm, please, here in the chat once you are ready, once you have the simulation prepared. Put some emoji here. Let me put here a waiting emoji, so that I'm waiting for your comments. Yes, okay, so temp is set up. Yeah, so we are synchronized, Ricardo. Right in the moment that you were asking to write on the chat, I have just written there my emoji. Can see the environment in gazebo. Yes, ha. Still waiting for it. I have nothing in gazebo. Okay. You have nothing, or you see a gray screen? Because it's different. Do you see a gray screen? Gray, okay. Okay, then this is the issue that I have just explained it. So let me stop and do it again. Okay, so once you launch the command and you open the client, the simulation appears zoomed. Okay, zoom it into the world. So you are going to see this, and apparently you can think that something is not working, but actually everything is fine. Okay, so don't worry, no errors here. The only thing is that you need to zoom out of the scene. Okay, so you need to come. You can zoom. Usually you are going to be able to do so with the scroll wheel here in your mouse. This wheel that you have in the center between in the center of the mouse, yeah. Usually with this wheel, I'm moving it, you can zoom in and zoom out of the scene. Okay, I am doing it right now. You cannot see it, however, but I am zooming out. See, with this wheel, here I am zooming out, and I can also zoom in, of course. Yeah. So initially the simulation is zoomed in, so that's why apparently nothing is working, okay? But just by zooming out, you are going to be able to visualize the scene properly, okay? Okay, I see it, works now for me, open it, gray screen. Okay, so for the ones who are having this gray screen, remember, you have to zoom out, okay? And usually this is done with this middle wheel, this small wheel that you have in the center of your mouse, between the left and right clicks. By the way, why does this problem happen usually? This is probably something related to the client cameras, which are misconfigured, okay? So this could be solved by changing gazebo configuration or how the camera is configured in gazebo. Okay, just setting the camera to a different angle would solve this. in theory. Works, says Dado, great. Okay. Okay, so let's keep moving. Let's keep moving then. So, okay, so right now, as I have mentioned it before, we have launched this simulation, but this simulation is based in ROS1, right? Because we are using a ROS launch command, which is a command from ROS1. In fact, if I come here, well, actually, let me minimize this shell because it's the one associated to the simulation. So I'm going to minimize it and I'm going to start working with a fresh new one so that I don't close by accident or anything the simulation. All right, so in fact, right now I can run a ROS topic list and I'm going to be able to see the commands and everything. So yeah, this simulation is based in ROS1. However, this conference is called ROS2 Learning Week, right? Okay, then what are we going to do? We are going to be actually working with this ROS1 simulation, but we are going to connect through it from ROS2. Okay, and I have just gotten disconnected here. Okay. Well, let's just log in back to the platform. Okay, there we go. So I have, maybe there's here a ghost or something that has just disconnected me from the platform. No. Well, okay. I will forget about it because if I don't, I'm going to get really scared. So let's go back to work. Okay. So yeah, let me minimize this gazebo screen, and yeah, so we are going to be working with this ROS1 based simulation, but we are going to connect to it from ROS2. And how are we going to do so? We are going to be using the ROS1 Bridge. Okay? ROS1 Bridge. And what is the ROS1 Bridge? Well, basically, it's a tool that allows communication between ROS1 and ROS2. And this is something very useful, especially now where ROS2 is still being created. So it's still in its early stage, let's say. Well, actually, it's already quite developed, but still there are many things, packages, simulations, and these kind of things that are not yet available for ROS2. Okay, so ROS1 has been there for many years, so there are many more simulations, many more packages available for ROS1. Then with ROS1 Bridge, we can use ROS1 in combination with ROS2 so that we don't miss anything. Okay? And that's what we are going to do right now, okay? So what we are going to do right now is to connect to this simulation through the bridge. However, I'm going to skip this for now, okay? I will come back here in a moment, and I'm going to jump here to this demo, okay? So right down here, these first ROS Bridge commands, you have this demo, okay? Which says run the bridge and the example, talker, and listener, ROS1, ROS2. So what we are going to do here is to, first of all, we are going to launch a ROS1 Bridge server. Then we are going to run a talker node, a publisher node, based in ROS1, okay? And then we are going to launch a listener, a subscriber node, based in ROS2, okay? And we are going to see here how the communication between the ROS1 publisher and the ROS2 subscriber happens, okay? So let's run this simple demo right now. So first of all, I'm going to run this command, which basically is going to source the bash rc bridge, okay? So what is this source doing? Okay, we can check it right now. So here, if you remember day one of this week, where we were learning some basic concepts of Linux, if I run an ls command, here I can see all these workspaces, okay? However, the file that I am running here, yeah, so this file is in home user, okay? And right now, I am here in home user, right? So in theory, this file should be here, but I am not able to see it. Why? Does somebody remember this from day one? Why I cannot see this file, and what can I do in order to see it? It's hidden. It's a hidden file. That's right. Okay, I can see that you remember this from first day. Yeah, so I can use the A attribute. LSLA also. LSLA. Okay, so if I run here LSLA, I'm going to see all the hidden files, and amongst them, I'm going to find here the bash RC bridge, also bash RC ROS1, and bash RC ROS2. Okay, these files are going to be the files that I'm going to use here in this demo. And I can see their content, for instance. Let's check what the bash RC bridge contains. I'm going to use the cat command in this case, okay? So the contents of these files are this, okay? So basically inside this bash RC file, what I have are different sources, okay? So I'm sourcing first ROS1 distribution. Second, I'm sourcing the ROS2 distribution, which is Foxy, and then I am sourcing other workspaces, okay? I can also check the contents of bash RC ROS1, which basically it's sourcing ROS Noetic, as you can see, and the Catkin workspace, and I can also check bash RC ROS2, which basically is sourcing ROS2, ROS Foxy, okay, and the ROS2 workspace. The workspaces that are related to ROS2 in this case, okay? So basically here I have three sources. One is going to source ROS1 distribution, another one is going to source ROS2 distribution, and I have the bridge source, which basically is going to source both of them, okay? Then, first thing I'm going to do is to source this bridge file. So let me copy the command from here and run it right here. And then I'm going to run the bridge with this command, okay? ROS2 Run, ROS1 Bridge, which is the package, and Dynamic Bridge, which is the executable. So let me run this command right here. And as you can see, some bridges have been already generated here, okay? Then I'm going to click on this Add button, which is going to open a new shell here, right here besides. So let me open a fresh shell. And now I'm going to source ROS1 right here, and I'm going to run this command. ROS1 ROS tutorial stalker. As you can see, this is a ROS1 command. Yeah, in ROS2 it would be ROS2 Run. So this is a ROS1 command. So I'm running my talker here, my publisher node in ROS1, and this is starting to publish. Where it's publishing? Well, I can run here a ROS topic list, for instance, in ROS1, and I'm going to see this chatter topic, okay? So this node is publishing into this chatter topic, this hello world. So for instance, if I subscribe using ROS topic to the chatter topic, I'm going to be able to read this, okay? Then, what I'm going to do here is to now source ROS2 and run this subscriber, which is based in ROS2, as you can see, ROS2 Run, okay? And now this node is going to generate a subscriber in ROS2, based in ROS2, which is going to connect to this chatter topic, which is based in ROS1, is going to connect to this topic using this bridge here, okay? And then it's going to start printing the contents. So let me run it, and we are going to start seeing here the hello world. And if we come to this shell, for instance, we are going to see that the bridge has created a bridge for the topic chatter with this type, okay? So we can see here that the bridge has been created and the messages are passed from ROS1 to ROS2, okay? Great, so let me stop all of this. Now let me stop the demo. All right, so we know that this ROS1 bridge tool is going to allow us to communicate between ROS1 and ROS2. Then what we are going to do now is that we are going to launch one of these ROS Bridge servers, okay? Let's come back again here to the ROS1 Bridge section. And what we are going to do now then is to first source /c bridge, and then we are going to run now the bridge, okay? So basically with this bridge, my intention is to be able to connect using ROS2 programs with the topics that are running in this simulation, which are based in ROS1, all right? So in theory now, if I source here Foxy, which is ROS2, and I run a ROS2 topic list, I should be able to see the topics from ROS2, right? But I cannot see them. Damn. Okay, so I have the bridge running. I am running here a ROS2 topic list, but I cannot see the topics. Where are all the command bell, ODOM, scan, all these topics? Where are they? Okay, so what is happening is that by default, running the dynamic bridge is not going to automatically generate the connections for the topics, okay? They are not going to be automatically generated. They are only going to be generated when somebody requests it, okay? So for instance, now, if I try to publish into one of the topics from ROS2, the connection is going to be generated, okay? For instance, if I try to publish here from ROS2 topic pop into the command bell topic, etc., the connection is going to be generated, okay? However, there is one option that we can use, which is, it's not this one, actually it's like this, okay? We can add, when we run the bridge, let me stop it, and let me put it here, but I'm going to add one argument now to this command, which is going to be bridge all topics, okay? Be careful, because here in the notebook, a couple of letters were missing, I have seen, I think. So the argument is like this, okay? Dash, dash, bridge, dash, all, dash, topics, okay? Bridge all topics. Then if I run the command with this argument, then now the topics are going to be generated automatically. So if I run a ROS2 topic list now, I'm going to be able to see these topics. See the scan, the TF, the ODOM. I'm not seeing the command bell though. Probably because nobody is publishing at this point. So that's why, yeah. So we have the common bell topic, right? But ROS topic echo. Oops. Echo command bell. Yeah, nobody's publishing at this point. So if nobody is publishing, if it has no messages, it's not going to be shown here, okay? However, as I am saying, as soon as I publish something, the connection is going to be generated, okay? Yelania, you have to zoom out the simulation here. Okay, you have the simulation zoomed in like this. See? So at the beginning the simulation is zoomed in like this. Very zoomed in. So you are seeing this gray screen, okay? So you have to zoom it out like this, like I am doing right now, in order to see the complete scene, okay? In order to zoom in and zoom out, you have to move the mouse wheel, okay? This wheel that is in the center of the mouse. If you scroll up and down this wheel, it's going to zoom in and zoom out the simulation, okay? All right. So far so good. Do you get the idea of this ROS1 bridge? Why we are using it? Can you post the right command? Yes, let me do it. Let me copy it from here and put it here. Okay. I think that in the notebook you have this letter missing here. So here I have passed into the chat the full correct command, okay? This is the command to bridge all the topics. However, we are not going to run this one, okay? So we are going to run and use the normal one. We are going to use this one, okay? Why? Because if we bridge all the topics from the beginning, of course, this is going to take much more resources, okay? So all the delays are going to be higher, etc., etc., okay? So for now, we are going to stick with this command, the default one, ROS2 Run, ROS1 Bridge, Dynamic Bridge. We are not going to bridge all the topics, okay? Why? Because of performance issues, okay? We want we don't want to take so much resources because we don't need to have all the topics available, okay? In reality, we only need to create the connection when we are going to publish into a topic or to read from a topic. Otherwise, we don't need for this, at least for this project that we are going to do, we don't need to have the connection there all the time, okay? So because of this, we are going to use the normal one so that we can save some resources, all right? So should we use this bridge every time we need to connect between ROS1 and ROS2? Yes, exactly, Mirna. If you want to communicate ROS1 nodes with ROS2 nodes, then you are going to need to use this ROS1 bridge, okay? Only for this. If you are only working with ROS1, then you don't need the bridge. If you are only working with ROS2, then you don't need the bridge. But if you plan to be working with ROS1 and ROS2 and combining and communicating their nodes, then you need to use this dynamic bridge, okay? And, okay, thanks. Yeah, so we are using it, let me just remind it, that we are using this bridge because this simulation that we have launched is based in ROS1, okay? But we are going to be now creating programs in ROS2. So in order to communicate the ROS2 programs that we are going to create, which are based in ROS2, with this simulation, which is based in ROS1, then we need to use the bridge. So that's why we are launching here the bridge, okay? Great. So let's keep moving on. Then we have completed the ROS1 bridge part, and now we are going to go for the actual code. So we are going to be generating the code. And I have decided that we are going to be creating one of the programs that we missed yesterday. So because of time limitations yesterday, do you remember that we couldn't do everything? And I asked you if you prefer to do this publisher and subscriber node, or if you prefer to do the custom interface section. And the custom interface section won this pool by 6-3 or something like that. So So then I decided that, okay, so if we couldn't do this yesterday, then let's do it today, all right? So today we are going to complete this write a publisher and subscriber note, and we are going to use this to create our code, the code that we are going to test later in the real robot, all right? What did I miss? I am getting package ROS1 Bridge not found. Well, probably you are missing the source. Okay, so probably you are missing this source here. Before running the command, you need to source this basher C bridge file. Now in the first web shell to run Gazebo, there are error messages. Here you mean? Oh yeah, I can see. Yeah, okay, don't worry. It's not important. It's not important, don't worry. The simulation is still going to work. It's saying something about compression and formats, but don't worry. Don't worry about these messages. Yes, okay. So, okay. Then, yeah, let's go for it. So we are going to create this program where we are going to combine a publisher and a subscriber. So basically, we are going to start by creating the package. And then we are going to generate a publisher, which is going to publish commands into the command bell topic in order to move the robot. And at the same time, we are going to create a subscriber, which is going to subscribe to the laser. Okay? In order to get laser data, and based on these laser readings that I'm going to be getting, I'm going to send one velocities or others. Okay? So, all right, then let's go for it. So let's go for it. Then, first command, we are going to create our new package. So let's come here to a new shell. Let's source ROS2 because we are going to be working with ROS2 right now. Then let's go to the ROS2 workspace SRC folder as we have been doing. And here I'm going to create my package. Okay, then here I have it. Remember that we can also visualize this package from the code editor, okay, which is going to allow us to work easily, in my opinion, all right? So here inside the ROS2 workspace, we have the package that we have just created, all right? Then here we are going to create this Python script, exercise 21.py, which we are going to place where, in which folder we are going to put this Python script. Let's see if you remember these last days classes, where I'm going to put this Python script. In resource, do I put it here? Yes, no, in test. Exercise 21 package. Okay, very well. In which one? In the first one or the second one? Child. Okay, very well, very well. In this one, very well. Okay, so let me create here a new file, exercise 21.py, and I'm going to paste this code that I have here. So, Control-C, Control-V. Okay, then let's finish the compilation and everything, and later we are going to review the code, okay? So, okay, let's go for the launch file. So, I'm going to create a launch file named like this. So let me create here the launch folder. Inside the launch folder, I'm going to create my launch file, and I'm going to put the code for the launch file, which we already know how it works. And then finally, I need to update the setup.py, right? Why? Why I need to update the setup.file? Why I need to update this setup.file and add this line here that I am adding right now? Why I need to add this line here to the data files and also this line here to the entry points? Why? To create executable from launch files. More or less. So the idea is there, but the construction of the sentence is not right. To make the package understand the launch and exe files. Yes. So first of all, what we are doing, first and most important thing is this line here. Here we are generating the executable. Okay, so from our program, we are generating an executable, exercise 2.1. Okay, that I can run and execute. Okay, and also I am doing here in this line here, what I am doing is to get the launch files from this launch folder. Yeah, so I am getting these launch files and I am installing them into my package. Actually, I am installing them into the workspace. Okay. So here inside, I am installing all these launch files, okay? Here I have it, for instance, yeah? And in order to do all this, I need this file. And I need to do this in order to be able to run the launch file, okay? So yeah, basically what I am doing is two things. Generate the executable and install the launch files so that I can use them, I can execute them. Okay, then can you show the source command again, please? Which one do you mean? Source command? Which source command do you mean, Krishna? The last two commands in the shell. In my shell? You ran just before. Which ones? This one? Here, the last thing I have done is to create the package here. Before creating the Python files, you run a source command. This one, you mean? Yeah, here I'm sourcing ROS2 Foxy. Okay. Why I am using this command? You tell me. Why I have to use this command? Source opt ROS Foxy setup.bash. To set up the source with Foxy. So here basically I am sourcing ROS2 Foxy version. Okay? Why? To be able to run ROS2 commands. So if I don't source the ROS2 version of ROS, I'm not going to be able to run this program. For ROS2 command, yeah? So for instance, let me open a new shell like here and try to run this command, okay? I'm going to do it here, for instance. Okay. So if I try to run this command without sourcing ROS2, what is going to happen? hey, command not found. ROS2, command not found. The system doesn't recognize this. But if I source the ROS2 distribution, then I can run this command, okay? So that's why I am running that source. So now I'm going to remove this. Okay. Okay, so yeah, we're done. So let's compile. Colcom build. And what else do I need to do? Am I done? Can I run the program, or do I need to do something else? Source install setup. Okay. Very well. Okay. There we go then. So before running the program though, let's analyze what's going on here. So let's have a look here at the code that we have. Okay. So first of all, as we have already seen in many other programs already, we are sourcing RCLPy and Node, and we are sourcing two different extra messages. One is the twist, because we are going to use this interface for the command belt topic, and also the laser scan, because we are going to be using this interface for the scan topic. And also I am importing these QoS related classes, which are the reliability policy and the QoS profile, okay? Don't worry just too much about this. Just keep in mind that when creating a subscription, as we explained it yesterday, you can use this one as defaults, okay? Actually, this is hidden here. So let me put it here so that it's not hidden. Okay, there we go. Yeah? So you can use these ones as default, okay? So don't worry too much about this. These are more advanced concepts. All right, then we create our class, exercise 2.1, which depends on Node. Then in the constructor, we initiate a ROS2 node, which is going to be named like this, exercise 2.1. Then we define our publisher with the create publisher function, and we specify the type of interface that it's going to use, which is twist, the name of the topic where I'm going to publish, and the queue size, okay? By default, you can use a 10 value for the queue size, all right? And how do I know that for this command belt topic, I need to use the twist interface? Somebody tell me, how do I know? Because I'm a genius? No. I'm not a genius. I know something. I know this. Well, in fact, I already know it because I have created thousands of programs like this. But how can you know that for this command belt topic, you need to use the twist interface? Does somebody remember? We explained this yesterday. Or let me reformulate the question. How can I know in an easy way which type of interface this topic uses? We have some answers here. Type find. We can check it out with ROS2 interface show or something. More or less. That is close. ROS topic type, this is a ROS1 command, though. ROS2 interface list, ROS2 topic info, there we go, very well. Kasim got it. ROS2 topic info is the right one, okay? Why? Because ROS2 interface commands can be used for the twist message, to know more about the twist message. But if I want to know which type of interface this topic uses, I need to use ROS2 topic info, okay? Then once I know which kind of interface this topic uses, then I can get more information about this interface with ROS2 interface, not info in this case, but show. It would be ROS2 interface show that somebody said here, up here, ROS2 interface show, okay? But the command to know information, which kind of interface this topic uses, is ROS2 interface, ROS2 topic info, okay? Let's have a quick look here, in fact, ROS2 topic list. Okay, yeah, we don't have the command belt topic because we are running the default bridge, but ROS2 topic info, for instance here, gives us the type of interface used by the topic, okay? In fact, I don't think it's going to allow us to get info from the command belt topic. No, it doesn't allow us because we don't have the connection. Okay, no worries. All right. Then let's keep seeing here. So next we create the subscriber with the create subscription function. We specify the type of interface, the name of the topic, and this here. At the end we have the QoS profile, okay? And this move turtlebot. What is this? This is the callback function, okay? This callback function is going to be triggered when? When is this callback function going to be activated? Need to wait here. This one. Like you are searching for the answer to the question. So when is this callback function, move turtlebot, going to be activated? Timer. No. Not with the timer. The timer is going to activate another function. This one. Self motion. Okay? But not this one. Move turtlebot. Okay, let me answer. I'll give you this one. So this function is known as the callback function of this subscriber. Oops, sorry. Okay, so this move turtlebot function, it's defined here with the subscriber information, right? So this is the callback function of this subscriber. Therefore, this function, move turtlebot, is going to be activated every time that a new message is published into the scan topic. Okay? So every time that a new message comes to this scan topic, this callback function, move turtlebot, is going to be activated, triggered. Okay? This is important to know. So each time new topic is published. Well, more or less. Okay? So every time a new message is published into this topic and not other topic. Yeah? So every time a new message is published into the scan topic, this function, which is defined down here, this function is going to be activated, okay? This is an important concept and idea to know, okay? And to understand. Okay. Then we are defining here the a period also, as we can see here. We are a timer, which is going to be activated every 0.5 seconds, so 2 times per second. And it's going to activate, in this case, this other function, self-motion, which is defined down here, okay? Then we have other things, like we are declaring a new variable, laser forward. We are creating another variable, CMD, which is going to contain a twist message, okay? Some other things being done here in the constructor, okay? Then in the moveTurtleBot function, which is the callback function from the subscriber, what is happening here is that I am receiving the full data of the laser, okay? All the data from all the laser beams. And in this case, I am selecting only one, the one which is in the position 359. And with this value, I am saving this value into this variable, laser forward, okay? So basically, this laser beam, the one in the position 359, is the one which corresponds to the front of the robot, okay? Then I am saving this value into this variable of the class, laser forward, okay? I'm doing only this, yeah? Then in this motion function, which is going to be triggered by the timer, I have, first of all, I am printing the laser forward variable. So I am printing it using the getLogger function so that I can see in the shell, I can see which is the value of this laser forward variable. And then I am analyzing it here. If this laser forward value is higher than 5, then I'm going to set this linear velocity and this angular velocity. If this laser forward variable is lower than 5 and at the same time is higher or equal than 0.5, so if the value of this laser forward function is between 0.5 and 5, I'm going to do this. I'm going to set this linear x velocity and this angular x velocity. And if none of these two conditions are met, then I'm going to set these velocities, 0, 0. Okay? And after this logic, what I'm going to do is to publish the values of the command variable. So I'm going to publish the velocities. Okay? Either if they are these ones, or these ones. I'm going to publish them to the robot. Okay? Then finally, I have the main function where I'm just initiating the ROS communication. I create an instance of my class, my exercise 21 class, and then I spin, okay? So the program will be running until somebody explicitly stops it, for instance, with a Control-C. And if somebody stops the program with Control-C, then I'm going to destroy this ROS2 node and I'm going to shut down the connection, the communication with ROS2, okay? Yeah? Does this make sense? Do you get an idea of the program? Yes, no? Something that you don't understand in this program? Does destroy node deletes all the previous communication values. No. Destroy node. No, destroy node basically is going to destroy the node generated here from exercise 21. Okay? This node that I am generating here is going to destroy this node. But there are going to be still some communications here because RCLPy, for instance, is initiated. So in order to shoot down all the communications, we need to run this RCLPy shutdown. Okay? Is it like destructor? Yeah, kind of. Yeah. You can think of it more or less like a destructor. Yes, exactly. Okay. So what we are going to do now is we are not going to run the code. Why do we need to define the move turtlebot method? Move turtlebot method. This one? Move turtlebot. We need to define it because this is the callback of our subscriber, okay? So every subscriber, always, okay, always that we create a subscriber node, it's going to have a callback function associated, okay? Always that we create a subscriber, like we are doing here, always this subscriber is going to have a callback function associated, okay? Always. We need to put it here in the definition. So we need to specify the interface used, the name of the topic we want to subscribe to, and a callback function, okay? So this is mandatory. Then we are defining this callback function down here. Yeah, makes sense. And this is mandatory because every time, so we are subscribing to a topic for one reason. Okay? It's basically to get its messages. Okay? Then every time a new message arrives to this topic, this callback function is going to be triggered. Okay? Then I can decide inside this callback function, what do I want to do with the data that I am reading from the topic. In this case, what I am doing is to get one of the values and saving it into another variable because I will be using this in other functions. Got it. Okay. This is important, okay? So every subscriber is going to have a callback function associated, okay? Then what are we going to do now? We are not going to run the code. Why? Because this code is going to generate a kind of circular movement, as you can see here, because I'm setting a linear x velocity and also an angular z velocity. And if I generate some kind of circular movement, this is going to become a bit of a mess, because in this case I have some... So this exercise is meant to be run, as you can see here, in the other simulation, okay? But in this case, I am running it here in this other environment. So if I start here doing a circular movement, probably I'm going to crash again these obstacles that I have in the middle, etc. Okay? So what we are going to do is that we are going to change a little bit the logic of the program, okay? What are we going to do? I'm going to leave you some minutes to you so that you can try to do this by yourself, okay? So what I want to do is that I'm going to start moving the robot forward, okay? Forward, only forward. And then when it detects that this wall here is closer than 0.3 meters, I'm going to stop the robot, okay? So the robot has to start moving forward in this direction, and whenever I detect with the laser reading that this obstacle here is closer than 0.3 meters, I'm going to stop the robot, okay? So we are going to basically change this logic here to replicate this behavior, okay? Let me repeat it one more time. I'm going to move the robot forward until it detects that there is an obstacle in front of the robot closer than 0.3 meters, okay? So I want you to write this logic into this function, okay? I'm going to give you like 5 minutes to do so, okay? Why not calling the motion function directly? What do you mean? We are calling it here. This motion function is being called by the timer. This timer, okay? In this example, does the robot movement keep for 0.5 seconds? Yes. Yeah. So we are going to be activating this function every 0.5 seconds. So 2 times per second, okay? Can't we call it in subscriber dev? Yes, you could do it, but it's not a good practice. It's not a good practice. Because, for instance, if for whatever the reason you stop receiving messages here, if for whatever the reason this topic stops receiving messages, then this function is never going to be called. For instance. What are the laser ranges? How is range 359 forward in robot? So the ranges are all the different beams that we have in the laser, okay? So the laser, which we have mounted here in top, this is, oops, I got too far away. This laser is sending constantly beams, okay? Here through the space. And in this case, we know that the beam number 359 corresponds to the beam right in front of the robot, okay? Right in is the one that goes in this direction, so it gets the data right in front of the robot. Okay? All right, so let's go for this exercise that I have presented to you, okay? I'll give you 5 minutes so that you can try to do it by yourself, and then I will come back and complete it, okay? So try to do it by yourself. Come on. It's going to be an interesting exercise. Okay, I'm back. Let's see what things have you said here in the chat. So beam left will be range 90 and beam right will be correct? Yep, exactly, Monk. That's correct. If self laser forward higher than 0.3, linear x 0.5, angular z 0. Else, perfect. That's perfect. Tesfa, that's perfect. So yeah, let's apply it. Then the logic is going to be, if the laser forward value is higher than 0.3 meters, then we are going to move the robot at a speed of 0.5 and the angular velocity 0, right? Then we are going to remove this elif, this else if, and let's put this like this, and else, so if the laser forward value is lower than 0.3, then I'm going to stop the robot. Okay, perfect. So let's now come and compile this code. So let me come here, call build. Let's recompile this with the new logic and source the workspace. And now we are going to run it. Okay, so what would I expect to see? I would expect to see my robot moving forward, and as soon as the laser value goes below 0.3, the robot should stop, right? So, okay, so let's see if this actually happens. Let me put the simulation somewhere around here. And here I'm going to run my program. So ROS2 launch exercise, it was exercise 21, right? Yeah, and the launch file is named also like this. Okay, so let's run our program. And we are receiving the laser values here. Okay, one thing that we can see easily here is that the robot moves too fast, right? So let's tune the velocity. So let me reset here the simulation very quickly. Service. If you want to reset the simulation, I'm going to source ROS1, ROS2, no, sorry, service, call, gazebo, reset, world. Okay, there we go. So let me very quickly reset the simulation here because clearly it's too high. Let me put it to 0.2, for instance. Something like this. Let's lower the velocity and let's recompile this. Come here, call build, and source, and let's run again the program. Okay, there we go. Let's see if you can see it better now. Okay, so we see the lasers here, how they start going down, and when they go below 0.3, the robot stops. Okay, still probably too high velocity, though, but we have been able to see the behavior that we were expecting. Okay, during the 0.5 second movement, if the lasers can't find some obstacle, will the movement be interrupted? During the 0.5 second movement, if the lasers can find some obstacle, will the movement be interrupted? It depends. It depends. It depends on if this value is count here. Okay, so this function is going to be executed every 0.5 seconds, right? So 2 times per second. However, this function is being executed more times, okay? So this function is being executed more times. Every time that a new message comes here, this function is called, so this value is updated, okay? Then, basically, with the program we have right now, this is going to depend on if when this function is activated, this laser value has caught the obstacle or not. Yeah, do you understand what I mean? Yes, okay. Very good question, by the way. That's a very interesting question, which indicates that you understand what's going on here. Okay, so very good question, Pochang Lin. Okay, well then we have basically completed our program. So what we are going to do now, at the final part, well, basically this is going to be, let me see one more question. Alberto, what is the best way of, okay, some questions here. Alberto, what is the best way of making a ROS program with lots of features? LiDAR, laser, path, planning. Should we make a exe including all programs? Make different exe for every feature? Different executables for every feature, for sure. Yeah. You cannot put so many things into one executable. Well, you can put them if you want, but it's not recommended. Because if you put everything into one program, then for deploying and for first for organization, second for deployment, third for security reasons. If your executable breaks, your whole robot is going to break. If you separate things into different executables, then you kind of have a security there, because even though something breaks, you are still going to have other systems available, etc. Okay, so the more you separate things, the better, I'd say. Make different packages for them. Not sure if we can run several packages in a single project, or you recommend something else. Yeah, you can put as many packages in one workspace as you want. You can have hundreds of packages here, okay? But the best practice always is to try to I'm not getting now the word in English, how to say, but the best practice is to try to separate things in a logic way, okay? Always. So for instance, put your the programs which are related to navigation in one package, okay? Put programs which are related with detections of the camera in another package, etc. Okay. Make sense, Dado? Does this answer your question? Thanks. Okay, great. So what I'm going to do now, because this final part, it's only the final part, okay, so don't worry. This final part, you are not going to be able to do it, at least right now, okay? So I'm going to do it by my own. But basically what I'm going to do right now is to connect to the real robot that we have right here in our office, okay? So I'm going to connect to the real robot, and I'm going to execute this program. So the same program that we have just created here and tested in the simulation, we are going to run it on the real robot, okay? I'm going to do this right now. So, before running this program in the real robot, I'm going to do two things, okay? First one is that I'm going to lower the speed here, okay? Because in the real robot, the speeds are different, let's say that, from the simulated version, okay? So in the real robot, we need to set much lower speeds. So in this case, I'm going to set a speed of 0.05, okay? And another thing that I'm going to do is that I'm going to change this value. Why? Because the laser configuration in the real robot is not the same as in the simulated robot. So in the simulated robot, as we have seen, and you have also asked some questions here in the chat, the value 359 of the ranges array corresponds to the laser forward data. However, in the real robot, the laser forward data corresponds to the position 180, okay? Because the configuration of the laser is different, only because of that, okay? So basically I have modified this value so that I get the correct laser forward, and I have also modified the velocity of the linear x-axis so that I put it lower, okay? Because the scale of the velocities in the real robot is lower, okay? Then, having done these modifications, I'm going to recompile one final time. By the way, this is still running, so let me recompile here. Colcom build. Oops. Colcom build. And source install setup bash, okay? So at this point, I'm going to basically close everything, because I'm going to stop here all connections with the real robot. So let me also put this like this again. There we go. Here I have the IDE. I'm going to stop the simulation, of course. So let me stop here the simulation. I'm not going to be working more with the simulation. So let me stop it. There we go. Simulation stopped. And, okay, so I'm ready. Then what I'm going to do, so by the way, you are going to be able to connect to the real robot also after the class if you want, in case you are a subscriber, okay, of the construct. In this case, the real robot lab, right now, it's not available for free users, okay? It's only available for subscribers. However, from time to time, we do open weeks where the lab, the real robot lab, both for the Turtlebot and for the manipulator robot also, we open them for everybody, okay? For free accounts also. So stay tuned, and so that in case that we have any open week, you are going to be able also to connect and to test these robots, okay? So right now, however, it's only available for subscribers, okay? So in case that here in the chat there is any subscriber of ours, keep in mind that you are going to be able to test this if you want also, okay? After the class or whenever you want. So right now I'm going to do the connection, which is super easily done. Here in this robot icon, I just turn on the connection. And right now I am being connected to the real robot lab, okay? So I'm going to wait a few seconds until all the connection is done. There we go. Perfect. Here I can see the real robot, by the way, the real environment, okay? This is live right now. So let me open a new shell. Then one more time, this robot, the real robot, is also based in ROS1, okay? I can run a ROS topic list, and I'm going to see all the topics here based in ROS1. So again, I'm going to have to do what? What do I need to do? Because my program is in ROS2, right? So the program I have executed, which I cannot see right now here in the IDE. Let me put this a bit smaller. Okay, here it is. So the program I have created is in ROS2, right? But my robot, the real robot, is based, as I can see, in ROS1. See? So what do I need to do if I want to run my program in the robot? Bridge, perfect, very well, okay. See, you command and I obey. So let me run the bridge. I have to source the bash RC bridge first, and second I'm going to run the bridge. There we go. bridge is running. Okay, so last thing I'm going to do now is going to source Foxy, right? Going to source ROS2, and I'm going to source also the ROS2 workspace, which is the workspace where I have my program, okay? There we go. I have the bridge running here, and then I'm going to run my program, which is ROS2 launch exercise 2.1, exercise 2.1, okay? There we go. So let me open here the robot view. So what I would expect now here in the real robot is the same behavior. So I'm expecting the robot to start moving forward, and as soon as it gets closer to this wall, it's going to stop. By the way, let me do one more thing. I'm going to do one more thing because I can see that the wall is there, so we are not going to see it very well. So I'm going to increase a little bit here the distance for stopping. So right now it's 0.3, so I'm going to put it to 0.5, maybe. Yeah, I think it's 0.5, okay? So when it gets closer than 0.5 meters to this wall that is here at the bottom, here, then the robot is going to stop, okay? So let me recompile. I need to recompile, right? So I have modified here the logic. Source, install, setup, bash. There we go. Okay, so let me now run my program, ROS2 launch, exercise 21, exercise. There we go. So let me put this here so that we can see it properly. And there we go. Put it a bit bigger, like this. And let me run right now the program. Okay. So let's see if everything works as expected. I'm going to start receiving, now it's 0, but this should be, okay, now I'm starting to receive the laser values. And now the robot starts moving forward, as we can see. And when these laser values gets below 0.5, the robot is going to stop. It's getting close to that. Okay, in the next reading, it's going to get below, so the robot should stop. There it is, okay? There we have how the robot has stopped. As you can see, there is a little bit of delay, okay? There is delay because of the connection, also because the bridge and this kind of stuff. But yeah, there you have it. So we have just run our program in the real robot. Our program based in ROS2, and we have deployed and run the ROS2 program in a robot which is based in ROS1 using the bridge. Okay? So yeah, let me already stop my program. And yeah, that's basically all. So we have finished it. What is the unit? Let me see here if I see some questions. What is the unit of the value we get from self laser forward? It's meters. Meters, it's the unit. So this is 0.34 meters. So 35 centimeters. Okay, so it's in meters. Is it based on ROS library in Arduino or some sort of Raspberry Pi? It's based in Raspberry, if I'm not wrong. This robot is based in Raspberry. Yeah. How Gazebo Real Robot subscribe to the ROS topics? How Gazebo Real Robot subscribe to the ROS topics? I don't understand this question, Dado. So the real robot, this robot has let's say has a computer. In this case, this robot has a Raspberry Pi inside it. And in this Raspberry Pi, we have ROS installed, okay? And then from here is where we are publishing all the topics and everything. And then we are connecting to these topics here from this project. Raspberry Pi 3. Okay, so Rodrigo, who is the person in charge of the lab, of the Real Robot lab, is confirming that the robot is running Raspberry Pi 3. Thank you, Rodrigo. How to communicate with real robot? What do you mean? How to communicate with real robot? There are many ways in which you can do it. You can connect through SSH to the computer of the robot, for instance, to the Raspberry Pi. You can use SSH protocol to connect to it. You can use OVPNs, which is our case. You can use ROSDS. You can use our system to connect to these robots in a super easy way. You don't have to worry about anything like you have just seen here. I mean, what is the supporting library where it was mentioned in the Python program? What is the supporting library where it was mentioned in the Python program? What is the I don't get you, Krishna. What library are you talking about? The supporting library you are talking about? I don't know what do you mean. I'm going to start switching here to my screen. Okay. Where in the program is it receiving the info from the real sensor? In the topic, Krishna. So let me switch back. Okay, so can you see my screen here? Yeah, okay. So for ROS, this is a very interesting thing from ROS. This is why ROS is so powerful. So for ROS, it doesn't matter if it is a real robot or if it is a simulated robot, as you have seen. So ROS only thinks in terms of topics, okay? So ROS is going to read from this topic the information, and ROS doesn't care if the information is being published to this topic by Gazebo, by a simulation, or by the real or by the real robot. ROS doesn't care about this. ROS only cares about topics and information. So ROS, our program, is subscribing to this topic and reading the data from this topic. But it doesn't care if the information is being published by the real robot or by a simulation. You see? So it doesn't matter to ROS this. That's why ROS is so powerful. You understand this idea? It's clear, yeah. So this is a very good question, but it shows the power of ROS. So we don't care who is publishing this information. We only care about subscribing to the channel and getting the information. And this allows that, as you have seen, the exact same program that we have run on the simulation, we can move to a real robot and run it. This is super powerful. Yeah, so we can run the same program for a simulated environment and for a real robot, as you have just seen. Okay? Yes, it's clear. If two robots listen to the same topic scan, will they perform the same behavior? Yes. However, Yeah, so if two robots listen to the same topic, they will perform the same behavior, yes. However, usually every robot is going to have their own laser. So every robot is going to have their own scan topic. It's not normal that two robots share a same laser. That's not usual. I have never seen it. So usually every robot is going to have his own laser. Can we visualize the point cloud from the laser sensor? Yes, you can. Yes. Let me show it very quickly. Okay. I'm going to launch here ROS 2. Okay. ROS tool. Do you know ROS? It's a very powerful tool of ROS. Okay. So ROS 2. I'm going to open here the graphical tools. And here we have ROS, okay? This is ROS 2, in fact. This is ROS for ROS2. So here I can select to add displays. For instance, I'm going to add a display for the laser scan topic. Let me add it right here. And then here in the display, I only have to specify the topic. So again, it's all about topics. So here, I'm going to put the topic for the laser, which is a scan. And let me increase a little bit the size of the readings. See? So these red things that you can see here, these are the laser readings. These are the readings that the laser is detecting right now. These red things, okay? Can you see? For instance, another thing that I can access also is the camera. So this robot, Taltebot, has a camera. So I can connect to this camera also. Let me show it. So I just have to select the topic for the camera, which is, I don't remember. Let me look for it very quickly. ROS topic list grep camera. Okay, it's CB camera image raw. Okay, so I'm going to put it here. CB camera image raw. So now I am connecting to the camera, okay? So I should see here what the camera of the real robot is seeing. Here I have it, see? So right now it's white because I am seeing the wall, of course. But I can, for instance, I can rotate a little bit the robot very quickly. Let me do it here with a couple of commands. With a teleop program, I'm going to move it a little bit. Okay. There's a problem. There's a problem here in the teleop. Here scripts print. Sorry about this. Print. Let me try to do this super quickly. It shouldn't take much time. Print. I just need to fix some things here in the code that are wrong. Have you seen? Print message. Okay. Also here. Okay, I think it's done. Let me run it again. Yeah, there we go. Okay, so now if I rotate the robot a little bit, let me actually put this here so that you can see it better. I'm going to rotate a bit the robot to the left in this case. See how the camera is changing the view? So I am rotating the robot to the left. See? So now I am getting basically I'm getting what the real robot is seeing, okay? What if I have two laser sensors to cover the whole range of environment? So which info does the scan will take? Well, if you have two sensors, then you can use some programs. There are some packages there that combine the information from the two lasers, okay? You can look information there. So, but there are programs already made. There are packages for ROS already made that get information from two lasers and combine them and publish it into a single topic, okay? So there are already programs that do this, Krishna. Is this print issue due to Python 2.3? Yeah, exactly. Yeah. So this program was written in Python 2, but now I am running Python 3. So that's why I was getting this program. So just by changing this prints to functions, which is compatible with Python 3, it solved it. Yeah. Okay, so yeah, guys, let me close it here. So yeah, thank you very much one more day for being here with me. We have completed the 5 days. I don't know if all of you have been here the whole week from day 1 to day 5. If you have done all the classes and you have been here all the classes, thank you very much. You are a real warrior and a real champion. And yeah, I hope you have enjoyed this week. I hope you've got some... you have learned at least something from ROS2, which is the goal, and it's my goal. So at least if I have teach you something, my goal has been completed. So yeah, again, thank you very much to all of you for this week. I will see you again in live classes, as always. So every Tuesday, 18 CST time, as always. So I will see you next Tuesday for the next live class. Then thank you very much. And until then, as always, take care and keep pushing your ROS learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day 1. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.